This is your second program about algebra. You will recall that algebra is the branch of mathematics which helps us solve problems about complex but logical relationships among quantities. Algebra is like the science of logic, which deals with the non-mathematical relationships between things or between events. If you're clever and have a good memory and notice everything which occurs in a situation, you may be able to solve some problems about some moderately complex relations between quantities without bothering to use the procedures of algebra. We do this every day with simple relations between quantities, such as computing the miles we drive per gallon of gasoline. But as the relationships get more complicated, most of us need to use the procedures of algebra if we're going to find our own answers to the problems. Some persons don't develop or sustain the habit of thinking logically about matters which arise in their lives, at work or at home. They act impulsively or emotionally without bothering to think about the results. But when complicated matters arise, it is helpful to be able to find some logical and effective way to think about them. The study of algebra will help you do this. In the first algebra program, we used letters or other symbols to stand for unknown quantities and learned some of the ways these quantities can be expressed. The most useful expression in algebra is an equation, which is a statement that one or more terms on the left side of an equal sign is equal in value to one or more terms on the right side of the sign. How could you define an equation? How might you describe algebra? Yes. We've already used the word term in algebra as made up of a letter or number, or several letters or numbers, which are multiplied together. 2xy is a term. Usually, however, we call it a term only when it is part of an algebraic expression made up of two or more terms added together. In the binomial 2xy plus 3y, 2xy is the first term. What is the second term? Yes. You recall a binomial is a polynomial with just two terms. Let's make up a simple algebra problem. Two cans of paint, which have an unknown weight, are combined with two 1-pound weights. They're found to equal a 10-pound weight. Which shows this? Yes. Of course, you probably could find a solution to this problem easily without algebra, but let's go through it for practice. The first thing we must remember is that the balance of the equation must not be disturbed. We may add a pound or two to each side or subtract it, but we must always remember to do the same thing to each side, or the statement about equality, which makes it an equation, is destroyed. To solve an equation or find its solution means to find the value of the unknown quantities. An equation is solved when the letter representing the unknown appears by itself on one side of the equation, and some specific quantity appears on the other side. X equals 3 or x equals 5 would be statements which solve some sort of equation, since x would appear by itself. In the case of our equation 2x plus 2 equals 10, it appears reasonable in simplifying it to subtract 2 pounds from both sides. What would we get then? Yes. Now we must take just one more step to find the solution. It's obvious that by dividing both sides of the equation by 2, we'll have the unknown x alone on the left side, which we've said means solving it. What will we have on the right side? The equation x equals 4 is the solution of our original equation, and the number 4 is called the root of the equation. In some solutions, as we will find in more complex equations, there may be more than one root, or correct answer. It hardly seems worth employing algebra to solve problems like if 4x equals 24, what is x? Or if x plus 5 is 15, what is x? But starting with these easy ones will help us grasp the concepts, which can later be applied to the more complicated problems. A supermarket has a cash register which returns your change automatically. If you gave the cashier a dollar bill for purchases totaling 57 cents, including tax, and your change came to you in pennies and nickels only, how many nickels would you get? Let n be the number of nickels and p be pennies. Multiplying n by 5 and p by 1 gives the value of the change received. This expression equals 100 minus 57, shown on the right side of the equation. Could you use this equation to help you find the number of nickels? 5n plus p equals 100 minus 57. Yes. First, let's subtract your purchases and see that 5n plus p equals 43 cents change. Now let's assume that we were given the smallest number of pennies possible, which would be 3. These 3 pennies are worth 3 cents, so we may replace p, the value of the pennies, by 3, and have 5n plus 3 equals 43. Now to get 5n by itself, what must we do next? Right. This would give 5n equals 40. To get n by itself, what do we do now? Yes. When we divide both sides by 5, we get n equals 8, meaning we got 8 nickels back from the cash register. This may seem to be a rather silly way to use algebra, but you can see that it can be a powerful way to solve more complex problems. Finally, even how to go to the moon or Mars. Some equations are general statements about things which vary in value or amount and are called variables. How would you define a variable? Right. The temperature of the air outdoors is certainly a variable. The speed of your car when you drive it is a variable. These variables may be related to other variables by rules in the form of equations. These rules in equation form are called formulas. We all know that the area of a rectangle is given by A equals LW, where area is A, and L and W are length and width. Similarly, A equals S squared for a square with 4 sides S, and A equals pi r squared for a circle, and so on. Here's an approximate formula for converting your speed in miles per hour to kilometers per hour. K equals 1.6 m. This means that if your car's speedometer read 10 miles per hour, you would be traveling at a rate of 16 kilometers per hour. If you were driving in Mexico and if you measured 50 miles per hour, it would be approximately 80 kilometers per hour. You can see that a formula equation like K equals 1.6 m is easy to use. You can make up a table or chart for various values. You could change the way the formula is written to K over 1.6 equals m, or 0.625 K equals m, or even 5K equal 8m by dividing or multiplying both sides by the same number, or by converting decimal fractions to common fractions, and so on. But there's not much algebra involved in this formula. Let's look at another formula you might have to use if, for instance, you went to a European country. Your Fahrenheit thermometer may read 50 degrees on a cool morning, but the local centigrade thermometers show only 10 degrees. And in the afternoon, when your thermometer rises to 68 degrees F, the centigrade reading is only 20 degrees. This is certainly not just a plain ratio like meters and miles. There's some adding or subtracting to do, as well as multiplying or dividing. Now, algebra seems a little more useful. The formula, as you may recall, is F equals 9/5 C plus 32. Or we could solve for C and get C equals 5/9 times the quantity F minus 32. In this case, you need to remember that the operation inside the parentheses must be done first. You can't just multiply the 5/9 by F or by 32 and not the other inside term. What do you think a centigrade thermometer would read when the Fahrenheit temperature was 59 degrees? If you noticed that a thermometer sign by the beach on the French Riviera read 25 degrees, you'd remember F equals 9/5 C plus 32. 9/5 of 25, of course, is 45. On the Fahrenheit scale, how warm is it at the beach? Good. You also see a lot of air conditioning thermostats in Europe set near 25 degrees. The centigrade Fahrenheit formula, which involves both addition and multiplication, is certainly not the most complicated use for equation operations, but it begins to demonstrate the usefulness of logical procedures to solve problems. A moment ago, we discussed variables. A variable might be the temperature or speed, the number of persons in a room, and so on. At any given time, a variable, of course, may have a certain value, but if you're interested in what happens when its value changes, you consider it a variable. Other quantities in a relationship you are considering don't change, at least not under the circumstances you're interested in. These quantities are called constants, and you may know their values, such as 9/5, or 1.6, or 32, or pi, so you write them down as a number, or at least a symbol like pi, which stands for a fixed number. What is a constant? Yes. There is another word you may meet in algebra called coefficient. In the formula, C equals 5/9 times the quantity F minus 32. The number 5/9 is a coefficient. This just means it's a multiplier written next to some expression number or variable. What's a coefficient? In the term 2x, what is the 2? Yes. The formula for the area of a square is A equals S squared, where S is the length of the four equal sides. What do we call the little 2? Of course. Where K stands for kilometers and M for miles, what kind of an equation is 5K equals 8M? Yes. What do we call an expression like 2x plus 32? Correct. When we have a binomial in the numerator or denominator of a fraction, or a binomial enclosed in parentheses, we must always perform the addition or subtraction before multiplying or dividing by outside coefficients. We'll practice this again in our next program. if we have reduced an equation to something like x equals 77, what is this called? Yes. In the solution equation x equals 77, what do mathematicians call the number 77? Yes. Another word used in mathematics is set. In ordinary use, this word means a collection of objects, set of chess pieces, a set of dishes, or a set of golf clubs. In mathematics, also, a set is a collection of things. The things in a mathematical set are called elements or members. In mathematics, what would you call a collection of elements? What branch of mathematics deals with relationships between quantities?